Good afternoon. So, an everyday life phenomenon that I'm going to talk about today occurs in my daily life, and it has for the last 20 so years. Today, for the presentation, I'm going to talk about baseball. So, baseball has a lot to do with physics, and it wasn't until maybe the last couple years that I realized how much physics actually has an impact on a lot of the things that occur in a baseball game. So, in baseball, there are many different forces that act upon the ball, the bat, and a couple of those things would be like the gravitational force, so the force of the baseball, the force of the bat, the ball traveling through the air, and how much the ball weighs, so the weight of the ball is the gravitational force. And then there's also aerodynamic forces that take place in baseball, so the air causing surface friction, the turbulence caused by what's in the air as the ball is traveling through the air. And another thing that occurs in baseball is that the ball can be deflected. There's a deflected flow, due to the spinning, the lift, and there's also an increased drag in baseball. So first I'm going to talk about what happens when the ball's in the air. So while the ball is in the air, as like maybe the pitcher's throwing the ball, there's a resistance that slows the balls down as it's being thrown. So the faster the ball moves, the quicker it slows. And there's a thing where most people know that some of the pitches that baseball players can throw can curve, so that has to do with like the drag force or what's occurring in the air. So as the ball is being thrown for the air, there's an actual laminar flow around the ball. It arrives at the front side and the ball squeezes together. So air at the front is really high and the slow air is from behind. The air must bend away from the ball's front and it's accelerated up and downwards. The air then bends towards the ball's side and must speed up due to acceleration. As the air reaches the ball's back and squeezes together, again while its flow bends away. So the pressures on both sides balance perfectly, and the ball experiences a little drag. So the turbulence that occurs in the baseball, so the ball travels at a certain speed, different people can throw the ball at different speeds. So the air on the ball's surface could cause the ball to slow down, or depending on how fast the pitcher throws, the turbulence could have an effect on how fast the ball is moving. Also, there is in baseball, the physics of baseball, there's a wake that forms behind the ball, and this brings up an unbalanced pressure. Another really important, as I mentioned earlier, the drag force in a baseball is very important. So baseball has been an important part of my life for 20-some years. I continue to play it now. I'm still playing it here at Rowan. So this is my first physics class here at Rowan, and as I go into my spring semester, I will be playing baseball. So it's going to be pretty neat to see and like take into my mind on how some of the things are occurring on the field, and like even the physics aspect of the whole thing. So it'll be neat that I learned about how baseball and physics correlate, and then to see it in motion in the spring is going to be pretty neat. So all the forces and the flows and the drag and all that stuff, I'll be able to like see it out there on the field and just be like, wow, that's a part of physics class. And I'm sure a couple of my teammates will call me nerds, but I enjoyed learning about how baseball and physics correlate, because baseball's a big part of my life and physics is something that I'm interested in. So I wanted to say thank you for a great semester, and I hope you enjoy your Christmas break.